Okay, so I think recording has started.
Usually it kicks me off video and audio, and that's not doing that. Okay, so that's good enough. All right, so quick intro on myself. Name is Grant Miller, as Dr. Haney already mentioned. I have been with IBM for just coming up on 30 years. So I've also been around quite a while. And so in the past, if I just think about my last 10, 15 years or so, I spent a lot of time in data and data security. I was with our chief data office that's part of IBM, and I actually led the entire security organization, around data. So I had a whole group that, we really worried about were people breaching, IBM stealing data, and what were they doing with our data. And one of the things that we really focused on with data, and especially data protection, is we always knew that data was critical to AI and for use in AI, whether you're training models or leveraging Gen AI systems or RAG models. We knew data was important. And so then I started getting into kind of the side of data and AI together, security. And from there, I kind of evolved and started looking a lot more into AI itself, and especially around identification and access and how do we do access controls. And so I really got very much into the IAM space, identity and access with respect to AI. I should say, I'll do a quick, I'll date myself a little bit. AI is, of course, has been around a long time. When I was at university and I did my undergrad work in engineering, AI was very new at that time, and we were doing neural networks and not very deep layers and some reinforced training and stuff. And so I actually did, my senior project was actually based in AI. So I've kind of been dabbling, in AI and security and different aspects of stuff for pretty much, in some way the entirety of my career. So I'm really honored, to be able to speak to everyone today, to kind of talk to everyone, share, my perspective on what I've seen, especially around, identity and access. And it really is very much an emerging area. It's a new space that's coming out. So it's really, really, I think, a great topic, especially for those who are, learning and trying to figure out where to go. As this field emerges, I think this is a great space. So I'm really thankful that, I was invited to come do this. So I know that was a bit of a long-winded intro, but I'll go ahead and jump in now. Let me share. I did create a set of charts. Let me share that with everyone. All right. Go into screen share mode. So, okay. So I've already talked about myself, a little background on me. So a little more background. I kind of want to go back about 15 years. And especially when we're talking about, are you human? Are you machine? Are you an agent these days? In 2010, I had a hard time just proving that I was actually a human. When we would do stuff on the internet, when we would do stuff on the web, there were at that time, and still even today, there were chatbots that would go off and buy tickets to sporting events or, overrun systems and take actions, right? And so you had to prove that you were actually a human, that my identity was a human. And this was really hard. Yeah, was there a question? Sorry.
No, no,
Okay.
no, no.
Okay, all right. I thought I heard something. So, you know, challenges came up. These were called CAPTCHA challenges. They actually were a kind of a Turing test to see if you were human or not. But they were really hard. So I put an example from way back, where you had to you were presented with a challenge and you had to type in all these characters and letters to show that you were human. But and this one isn't too bad, but it got really hard. There were times when I was trying to prove to a system that I was a human, that my identity was human. I couldn't even do it. It would challenge me again. It would challenge me again. So I actually saw this as a challenge and a problem, and this will tie in a little bit. So I came up with a solution. So if you go out on the web today, um, and you get challenged with, pick all the crosswalks or pick all the street lights, pick the stop signs, pick the cars, pick whatever it is. This was actually, there was a group of us in IBM that decided to come up with a better way that a human could do pretty easily, but we felt like a machine, and artificial intelligence couldn't do as well. So we actually came up with this, and we had a patent. So back in 2014, we actually issued the patent on this. So if you've ever come across this in the web when you're trying to do stuff, you can basically blame me on this, right? So I apologize up front. For creating this, because a lot of people like it's also like the squiggly lines. Now, how do you do it? But here's my point. There's actually a couple points to this. The first point is that, it's for a long time now, we've been trying to figure out distinctions or how to distinguish between like humans doing tasks and agents and AI doing tasks. And the second thing that I really want to push here, and we'll kind of have this throughout this whole thing, is your invention or solutions to problems. You really don't sit back and say, I'm going to invent something that's completely new and different. What really happens is that you're challenged. A problem comes up and there's not a good solution for it, and you have to come up with something. And as we go through this talk today, through different slides, I'm going to present you with challenges that we're actually facing right now. And these are the challenges that are waiting for people to come up with solutions and ideas and proposals around, right? And they're not necessarily big leaps. When you talk about invention, when you talk about, intellectual property, it's really about small steps forward. So I really invite you as we go through this, to really think about that. Where can you make these small steps? Where can you do invention? Where can you help us, as we start really figuring out the space of, identity around humans and agents and AI. All right. All right. So let me just start here. So let's back up a little bit and talk about how kind of did we get here? When we talk about identities, how did this whole thing come about? Of course, you can go back thousands of years, right? And how did people identify themselves? Well, really originally it was, you wore certain clothes. You had clothes that identified who you were, a priest or whatever it was. There was jewelry, there were rings, there were family rings that identified, a person. But just the fact that you were wearing it was enough to say, hey, you were part of this family, or you were a particular individual. In the 15th century, there was actually an act that was introduced. King Edward, I think, King Henry, that basically came up with the idea of a passport. So there really wasn't a good way formally to identify people, especially as you crossed country boundaries. So it came up with the concept of a passport. And a passport basically says, here is who I am. This is my identity, right? And here is what I'm authorized to do. Right. So if you cross boundaries, if you crossed into different locations around England, you could say, here am I, and here is what I am representing, and here's what I'm allowed to do. Now, if I jump a little ahead a little bit, if you think about how we do identity today, there's identification, who are you? There's authentication, which is proving your identity. And then there's authorization. What are you allowed to do? So passports were really the identification, right? It said who you were, and what you were allowed to do. And if you could take this passport, from somebody and present that, if you impersonated someone by using their passport, you could say, here's my identity and here's what I'm allowed to do. There really wasn't much in the way of like, how do we prove that I am who I say I am? And this was actually a problem. And we'll talk about that, through the early parts of identification. And then, of course, in the 1800s, we had photographs started emerging. Photographs, were used for identification cards. So now we could actually bring the authentication piece in, right? So you had an identification that says, here's who I am. You had a picture of yourself. So the picture was the authentication to prove your identity. And then in some cases, it said I'm allowed to travel, I'm allowed to take certain actions, it's diplomatic, I can do certain things, right? So the whole concept of, even today, as we think of identification, authentication, authorization, all of that is rooted in hundreds of years of us just trying to figure out how do we know who we are and what we're allowed to do. All right, so then we kind of get into the computer age. And we start thinking about digital identities. So we can go back, 60 years, when mainframes really started first popping up, and people wanted to store files on computers, and they had to have some sense of, well, who did these files belong to? And so there was an identity, some sort of a very simple form saying that here is the user of this computer system, and here's the data that they're storing. We also did a lot of time sharing back in the 1960s when mainframes were around. They were very expensive to run a program. So what you had to do is you created a program and you scheduled it to run. A lot of times you ran it overnight because it was a lot cheaper to run it overnight when the business wasn't running. So you did time sharing. So you had to know what is my job? That's what they were called. I wanted to run a job. Who owns that job, and when do you want it to run? So we had to, again, kind of start thinking about identities. Then networks came up in the 70s, and now you could be across multiple systems, and you tried to do a whole lot of stuff across these multiple systems. And again, we had to know who the person was, what is it they owned, what are they allowed to do with across the network. So we kept running into these same concepts that we've been running into literally for hundreds, if not thousands of years, but now it's all in the digital age. And so this really started forcing us to say, well, how do we manage all these identities? How do we manage giving someone identity? How do we manage what are they allowed to do? And this is what really started emerging as what we see today is, identity governance and administration, which is IGA. And that's kind of the core of what is around now, around really managing identities. And this really didn't really start popping up till the early 2000s. So it's been around, in relative terms to how we've been managing identities only for the last 20 years, for a very short amount of time. All right. Let's jump kind of into the AI and agentic world. So yeah, I have some stuff, here on agents. There was actually a Radio Rex. It was a teddy bear. It was a toy that you could talk to, and it would respond back. And this goes back over 100 years, right? I mean, so for the last 100 years, we've been trying to figure out a way to have machines that can interact with us and respond to us and do stuff, right? So it's really not a new concept. In fact, actually, in 1950, Al Turing actually came up with a test to say, are you human or are you not human? Right? How do I determine if something is human or not human? And that was part of what I showed, a few minutes ago on basically a Turing test that you run into the internet to say, hey, am I human or not? And of course, IBM had, our Watson. We've done AI for quite a long time. We had in the Jeopardy game on television, we actually had an AI that could respond to questions and give answers, right? Or you give answers in the form of question in the game of Jeopardy. But we showed, almost 20 years ago how an artificial intelligence could interpret a question and respond and give an answer back, right? And then, of course, we've made huge advances in AI in just really even in the last decade or so. And now this is leading to a real explosion, which I know everyone is seeing, and this is why you're focused on AI, is in the use of AI. And of course, now we have this thing called Agentic, which has emerged very recently, and we'll talk about that. But really, and this is kind of at the core of what I want to kind of get into today, is what do agent identities look like? You know, we've worried and thought a lot about human identities over thousands of years, over millennia, but now we're really starting to think about what does an agent identity look like? All right, so to kind of get into this a little bit, again, we're going to kind of go backwards and kind of talk from a identity and access management, from a governance, from an IGA perspective. What do we do with human identities? And again, I'll kind of position this the way we think about identity. There's identification. Who are you? Who do you say you are? Authentication. Can you prove who you say you are? And authorization. Then what are you allowed to do? All right. And so for humans, we're unique in that we actually have a physical presence, right? We have a physical identity, but we also have multiple digital identities. I have a digital identity that I use at work. I have a digital identity I use for social media. I have digital identities that I have at my bank. So I don't necessarily have a single digital identity. I have multiple of those, but they tie back to me as one physical identity. And of course, if I think of my work identity, I report to a department, I have a title, I'm a distinguished engineer, I work for the CIO office, I have a location, I'm located in the United States, and I have things like emails and all this kind of stuff. When I think about authentication, now this is an area, especially with the challenge of can you prove who you are, and to some extent can you prove you're a human? How do we really authenticate ourselves? For a long time we used passwords, right? You had a user ID, you had a password. Passwords are easily, in many cases are easily compromised. You can think of what they are. They're your street address, their birthday, they're just password, whatever it is, right? So we've started using other things like passkeys, something that we can tie more specifically to you, that you don't have to enter something, but you can tie it to a chip in your laptop, or it goes to your email, whatever it is. But there's some way, an alternate way that you can be challenged with proving who you are, and then we take an alternate path to actually do that. There's multi-factor authentication. You get a text to say, please enter these numbers, to prove, a secondary way to prove yourself. And of course, we have a lot of biometrics popping up now, facial recognition. I use my fingerprint on my laptop to prove who I am. So we're really getting pretty good at advancing our ways of authenticating and actually saying I am who I say I am. And then, of course, in a work perspective, from an authorization, I have to go request. Most of the time, I have to ask. I need access to my bank account. I need access to systems inside of work, and someone has to understand my identification, understand that I proved who my identity was, and then say whether I'm allowed to do something, right? And as a human, I perform jobs, I leverage processes, I leverage tools. So there's a lot of stuff that I take advantage of to do my job. And all this is wrapped up in, who I am, proving who I am, and what am I allowed to do. On the right here, and I'm going to have this picture kind of, we'll flow through this, is basically the fundamentals of an identity governance and administration system. So there's some way of provisioning. I have to say I want to be part of a system, and I need to be assigned an identity to that system, and that is created and provisioned, right? And a lot of times it goes into an enterprise directory or an active directory, somewhere stores who my digital identity for this environment, who that is, what that is, right? And then of course there's authentication systems that say, okay, you're stored, we've provisioned you as a digital identity in our system, and you need to prove who you are, right? And that's through passkeys or whatever it is, right? And then of course there's access controls. That go off of the authorization. What am I allowed to do? And they control access to data, and the different systems. So this is really kind of at the core of how an agent, or not an agentic, a governance, an identity governance system works. All right, oops, it's not advancing for me. Oh, yeah. So other things we have to worry about when we really think about identity system. So it's not enough just to talk about provisioning and authentication and what are you allowed to do, but there's a lot of compliance requirements. Can we prove that I'm allowed to do the things that I said that I'm allowed to do and who I am? So we log things, right? We log it. We can go back. We can use that for audits. We can use that for IBM. We have a lot of controls in place around financial information. So can we prove that we have the right authentication in place? Can we prove the right controls? So we do a lot of this in compliance. And of course, I have the human figure here kind of inside of the system, but we can also dial in, right? I work from home a couple days a week. And so I need to be able to connect in securely, prove who I am again, and take the actions that I want to kind of take. All right. Let's switch over to non-human identity. Same kind of concept, right? These have popped up and have been around for quite a while too. And they're basically, they do have a unique identity, and a lot of times they're a system. They're a system that's inside of an environment that we want to give access to things, or it's an application, or it's just a function, right? There's just a simple function that I want to give access. So the concepts are still very much the same. It's even if it's not human, it still needs to perform tasks, it still needs to do work, and we still need to identify who it is and prove who it is, right? So these things still exist. When we talk about authentication, how do we authenticate a non-human identity? Well, this is API keys, right? You write a piece of software, you write an application, and you want to connect to something else where you use an API key, or you use a service account, or you use OAuth tickets, right? Like JWTs or JOTs or something of that nature. So there are ways that you can connect and say, I'm allowed to do this, and here's the system that's doing this. And of course, the authorization is, you don't really request the authorization, it's configured, right? You configure a system to say that if I get this API key, I'm going to allow it, right? And of course, you're going to perform tasks. Now, one interesting thing is we talk about non-human, and we want to talk about what they're capable of doing. They still perform tasks, but they're deterministic. And what this means is when you write a process or you write an application that's going to connect the data, you've already determined what the steps are, right? You're going to connect to this application, it's going to connect the data, and you're going to flow all this information back. So it's structured, it's predefined. When you talk about our traditional non-human identities, it's predefined what they're going to do. So it makes it easy when I talk about authentication and we issue an API key and that's configured because we know exactly what that system's going to do. So we can kind of, build that all into it. So this is a non-human identity. All right. Compliance is still also very big part of this. What were the systems doing? Do we have a log of what they were doing? Can we show that as part of an audit that we do the right things and have the right controls in place? All right, let's switch now and start getting into agent identities. And this starts getting, a little bit more interesting. So we still have to have the concept of a root, of an identity, right? And agents are interesting because there may not necessarily be one agent. So there's an agent that performs a specific task, but there may be that task may need to be repeated 1,000 times a day. So we may actually have multiple of the same agent instances of it, like you would in cloud computing. You have a container, you spin up a container, and you have an application and a cloud container. Well, you can have thousands of those, right? All performing basically the same task. Agents the same way. You could actually have multiple of the same agent. So you have a root identity. Here's the agent, and here's who it is and what it's allowed to do. But then there may be 1,000 instances of that agent. So now we're starting to get some complexity into this. And we start thinking about things like identity context. So it's not enough just to say it's an agent and it does a specific task, but what's the context within which that action is going to happen? In other words, is this part, one of the things that we want agents to be able to do is work on a lot of different, do a task, but for multiple different processes, right? That task may be requested to happen from a lot of different ways. So what's the context of it? Who's asking for that task to be completed? Why are they trying to perform that task? And that really, we start thinking that as the context, and that becomes part of the identity, not just what the agent is and what they're trying to do, but who is the one trying to get that agent to do something, right? So we have to take this all into account. And of course, agents are similar in the sense that they'll belong to a department, they'll have a role, and they likely will have a location, right? We see this a lot, when we saw the privacy rules and laws coming out, we saw a lot of countries and regions start doing regulations around, what do you do with personal information. We're already starting to see this with agents as well, right? So where can an agent run? So if an agent's could perform a task in Europe, then that agent needs to be in Europe, and it needs to kind of belong to some sort of an organization in Europe. And so we're starting to see these regulatory things come out. So location of an agent is starting to become something very important. So that's identification. When we think about authentication, it really is starting to get a mix. We really think of it more like an application. It's a piece of software, and we're going to instantiate it as a compute object, and it's going to perform tasks, right? So we really, from an authentication perspective, start looking at it more like we would other non-human identities. Systems, computers, software, those kinds of things that we talked about before. When we talk about the actions it can take, it performs jobs just like a human does. It actually utilizes tools just like a human does. And the difference between an agent identity and traditional non-human is it's not deterministic. What we want in our agents is to be presented with a problem, a task, right? I need to find out some information. I need to find out how to do something. And there'll be some intelligence there to figure out what it needs to do. So, how it interacts with a system, with tools and processes, may change every time. So, it is not deterministic like we have been doing for the last several decades. Now it behaves more like a human. It could do different things. And this is why when we think of how do we authorize that, right? If it's going to change and it's going to figure out what it needs to do, how do we authorize that? Well, this is where the context starts coming into play here, right? And so what we want to do is we want to do what's called just-in-time approval, right? So we don't say what an agent is allowed to do all the time. What we say is, what is it trying to do? What's the context for what it's trying to do? What are the things that we know about this agent, its location, those kinds of things, its role? And then we make a determination just in time for it to do its thing based on the context of it. So these are all very new and different things. And if we look at our IGA system, it largely stays the same, right? We have to provision the identity for an agent. We have to somehow do authentication. How are we going to authenticate it? How do we provide the just-in-time context access controls? And how do we log all that so we have proper compliance? So this is where I'll present my first challenge, right? Kind of like I was talking about, for those, I know a bunch of people have come in a little bit later, but at the very beginning, I kind of showed a problem that I had been faced with 15 years ago on identifying myself and came up with a solution. And it was because I had a challenge, right? I didn't know how to do that. There are things here we don't know how to do. So I pose this challenge to you. How do we represent agent identities in an identity and access management system? How do we do that in an IGA system? So this is my first challenge to you, as students, is things to start looking at is how do we represent this? We have an idea of how we want to do this, but we don't know yet, right? So this is still an emerging space. All right, and we still have humans involved in this. All right. So I've talked a little bit about this. What makes AI identities different? Well, first of all, they're dynamic. There's no fixed. They're not deterministic. There's no structured flows, right? So they're very dynamic. They're going to be doing stuff. There's also complex handoffs, and we'll get into this in just a little bit, where it's not just an agent that's going to do everything, right? It's going to work with other agents and other systems and determine its flow, right? So it has to delegate. If I as a human say I want an agent to do something for me, it has to delegate that task to other systems, right? And to other agents. So delegation is adds a lot of complexity to this. And there's going to be complex interactions. It has to talk to multiple systems. And so all of these things, not only is it difficult for us to figure out what an AI is and how to represent it, but we know it's going to interact in very complex ways. So when we think about identity and access, when we think about governing that, this adds a level of complexity that honestly today's systems aren't really well, good at handling, right? So again, we're starting to think about how do we do this. So let's jump. I'm going to make a little bit of a lead. That kind of sets us up on some background of identity and access and human versus non-humans and agents. So let's start talking about AI. And so this is very simple. I know y'all have been studying AI, so this hopefully is nothing new. But if we think about a Gen AI, generative AI systems, and even RAG models, which are retrieval augmented, generative AI systems. Basically, what happens is you have a person, you have a human, right? And they talk to an agent or they talk to an assistant and say, hey, I have a question. Summarize this document. How do I do this? Whatever it is. It goes into an AI system. It talks to an LLM, a large language model, which understands the prompt that the human is asking for, understands how to interpret that, break it down, understand the information that's available to assemble back to respond to that prompt, and then bring that answer back, right? And a lot of times we do that through vector databases. There's a lot of information, right? So we have a lot of data. Again, I mentioned at the beginning, I come from a data organization, a data background over the last 15 years. And it was really like, how do we get data either to train or be used in prompts? And so we have to embed that into vectors, that feeds into the AI, and it all feeds back, all right? So very simple. You ask a prompt, you get a response back, from a generative AI system. So let's talk a little bit about the risk there, right? So there's prompt injection. So I'm doing a prompt, but I can structure my prompt so that I can try to get the AI, the model in the background, to go out of the range of what it was trained so that I can make it do something else, right? I can force it to give me information that it really wasn't trained to give me, but I engineered my prompt such that I can force it to do that, right? There's data poisoning. So if we think about the data that we're training, right, and a model on, if I can somehow manipulate the data that's being used to train, I can force the output of that training to be something I want, right? So I can actually change the way that model is going to work by just manipulating the data in the training. There's how do I do a denial of service? Denial of service is a traditional thing. We can do that for models as well. Supply chain vulnerabilities, and then these last two, which I really kind of want to get more into. And one is, how do we prevent an AI system, especially in Gen AI, from giving access to sensitive information that someone's not allowed to have, right? So this is actually one of our big problems, and this ties back to identity. We have to know who the person is. We have to prove who the person is, the authentication, and we have to understand what they're authorized to see. And an AI system has to know how to do that. It has to know who you are and what you're allowed to see so that we can make sure we don't disclose information you're not supposed to have. And of course, the other thing is excessive agency. We don't want an agent to have too much power, right? To do too many things. We don't want them to have the ability to connect to everything in sensitive systems and go everywhere, right? Much like a human, we really want to minimize that so that they're only allowed to do specific tasks. All right. So we'll kind of set that up. So let's let's talk about sensitive information for just a second. So there's lots of sensitive information. If I kind of blow out my diagram a little bit, there's financial information, there's HR information, there's sales information, revenue information. There's lots of information that we're trying to bring in. And here's the problem. When we bring information into a vector database from all these different locations, we mix and blend all this information together. So now instead of, in the past, we would say that this person, we know who they are, we know we've proven who they are, and we've authorized them only to access financial information, but not HR information. And we can do that in a traditional sense. If they try to go to the HR database, we'll deny them, right? But now we blend all this information so that we can train a model, and the model knows how to get to all this information, and now it's all mixed together. So how do we provide those controls back so that we can make sure that whoever's requesting it is actually only allowed to see certain things? I would also say, when we're talking about agents, that agents also should only be allowed to see certain things, right? There's a concept of least privilege. Least privilege says that you only have access to the information or systems you need only to do your job. So if we talk about agency, what an agent is allowed to do, we should actually minimize that as well, right? And say that an agent can only perform a specific task. And that then talks to their agency, and it talks to what they're allowed to access. In other words, an agent may not actually be able to see financial information, or it may not be able to see HR information. And what we do with this is we look at the human that's prompting and requesting, and what's their least privilege, what are they allowed to see? We look at the agent and we do a union of that, and the minimum of that union is what this system is allowed to connect to. So we have challenges in how we kind of build this whole system out. Now that's actually a whole nother topic. I have some strategies over here on how we start protecting data, but we could spend a whole lot of time on that, and we could actually do that, as a follow-on. But the thing that I want to kind of present here is the challenge. Again, right, another challenge for you is, if we know that data is coming from a lot of places, all sorts of documents, emails, all these things that you feed into your model to train, how do we protect that? How do we make sure that all that information being brought together, that we understand what the parts are, so that when someone is asking for it and we know who they are, how do we make sure that we're only passing the information back that they're allowed to see? And so that's actually a challenge we're tackling. There are approaches to this, but I would present it to you as a challenge to think about. All right, let me get into agentic systems now. So first is kind of a bit of a definition of what is an agentic system. So it's a system or program, and it autonomously performs a task, right? You don't have to, initiate certain tasks. It figures out what it needs to do, and it goes and does it, and it does it on behalf of a system or a user. In other words, I start off on the left side of this and say, I would like to perform a task that says that I want to change the salary of one of my employees and give them a promotion. And an agentic system, if I do that, so the C at the very front of this, oops, sorry, let me go backwards. The C in the very first of this is like a chatbot, something I have to interact with. I have to say, look, here's my problem that I'm trying to solve, and that chatbot or an assistant needs to connect to an LLM and understand what it is that I'm asking for. Then it goes to this R box, which is a router, and it figures out, okay, what's the problem? Where do I route this request? And in this case, it's an HR system, and I go off to an agent. The A is an agent, and in the case of IBM, our HR system is actually not our system. It's a SaaS model. So in this situation, I would say, look, I'm trying to change my employee's salary. It has to now go outside of IBM, go to another company's boundaries, go to a router in there, and finally go to an agent and say, okay, here's the task that I'm trying to perform. And so we have to understand what the task is. We have to understand who I am. And does the employee work for me? And am I allowed to actually take that action? And so what I've drawn in this is, if you see the red A down here at the bottom, this is a bad actor, right? This is someone, maybe it's the employee, maybe it's one of my employees who wants to change their salary, right? And they're going to impersonate me and pretend it's me and have an agent of theirs connect to an agent. Now we just have agents talking. And the agent, the red agent, the bad agent says, look, it's Grant Miller. And the other agent says, okay, Grant Miller's allowed to do these sort of things. So we're going to go let you change the privileges. If I go back to where I started, and I started talking about where we came from around identities. Remember, I said, you had a passport, right? Back in the 16th century, we started with the concept of a passport. You had papers, right? Your paper said, here's what the person identified in the papers is allowed to do. And it didn't necessarily prove who the person was, but it just says that the person that carries these papers are allowed to do this task, right? And if somebody intercepted or stole those papers, then they could present those papers to someone and impersonate someone and say, hey, here's the task that I'm trying to do. If I look at the way authentication systems work today, it's a lot like that. If I take an OAuth 2 token, a JWT token, it basically says, here's the identity of this person, and here's what they're allowed to do. If I start on the left-hand side of this process and I'm flowing it through, if somebody intercepts that token, that JWT, that OAuth token, they can replay it because you're not proving that it's actually me on the back end of it. All it says, these are my papers, right? So if you intercept that, now I can have an agent, a bad actor, a bad agent. It takes that identification, that token, and it passes it along, and it can actually now take actions that it should not be allowed to do. So here's the challenge. So I'll post the other challenge that is, again, something that not only IBM is working on, but the industry as a whole is working on, is how do you propagate the identities such that you can know with certainty and trust. So trust is hugely important here. How do I trust when I get back into company B that the person that requested, when it says, here's the person that's requesting this action, how do I actually know that it was me that initiated that whole thing? And so there's things going on around OpenID Connect. OIDC-A is a new standard that's coming out. OAuth is looking at, is there a new update to OAuth 2? Because they're really not designed for managing this. So this is the next challenge I will kind of present to you. Real quickly, this is just a good view of like how an agentic world is structured, right? There's assistants at the top. They can talk to multiple agents. Those agents can talk to multiple tools and data and everything in the background, right? It's kind of more of a framework view of what I was just showing. This is also delegation patterns. This is nothing, I won't spend a whole lot of time, but I'll make these charts available so everyone can see them. So basically, there's certain identity propagation and delegation patterns that we look at. One is there's no delegation, right? I tell a system, do a task, and that system is allowed to do the task. It doesn't know anything about me. It just performs the task and does the results. There's simple delegation, which says that my identity is propagated through that what happens on the far right is what I'm allowed to do, and I have to, and that goes back to the problem I was describing. There's assertions, there's SAML assertions, so we can assert who the user is and what actions they can take. And then there's also on behalf of. In other words, an agent has certain privileges and rights, and it's going to act on my behalf. And so this is the union of least privilege I was talking about. So now you have two things operating. One is an agent on my behalf, and I want it to do something, but that agent also has to be able to have the rights and privileges to do that. So we have to kind of look at that as well. So when I talk about identity propagation and delegation, there are multiple models around this that we have to kind of take into consideration. So let's talk about, I want to make sure I leave some time for questions, and we're getting close to the end here, but I want to talk a little bit about what's our strategy for governing agents, right? In an agentic world, right? First, when we kind of talked about this on a previous slide where I mentioned about how we identify non-humans, and really they have to have some sort of identity, and we're leading somewhere between, are they a system and software, which I mentioned before, or are they really more like a human identity where they have a manager, they have a role, and it's probably going to be somewhere in between, right? And then of course the context is very critical here. We have to have narrow access, right? So this is the least privilege, right? That an agent should only perform really a specific task. If you think of it in terms of computer science and you think in terms of object oriented, this is high cohesion, right? We want loose coupling and high cohesion. And the high cohesion is an agent does one task and that's it, right? And if we know that, then we can really start thinking about the context of what it's trying to perform that task. And then we think about the fact that it could be very ephemeral, right? It only lives, an agent could just pop up, do a task, and go away. So we have to take that into consideration when we're doing our IGA part, right? What are they allowed to do? The other thing, and this is another important thing, is segmentation and isolation. So this is a cybersecurity kind of thought, is that we basically isolate off the agents, right? We give them narrow, high cohesion to a task, right? They only perform a specific task, but they can only perform that against a specific system in a specific subnet or area of a network of a system, right? So we really limit what the reach that they can have, right? So this is segmentation and isolation. And of course, we always, and you'll hear this a lot, HIL, human in the loop. We always want to make sure humans are observing, monitoring, understanding what's going on. A lot of this is for auditability, regulatory compliance, those kinds of tasks and things. All right. All right. So here, let me do my closing thoughts real quick on this, and so I can open up some questions. First one, and we talk a lot about this, is AI. AI is happening at a speed that is really unprecedented, like the change that's coming out. Things that literally, there are things that I thought were true of how we were going to do stuff last week that is already changing this week. And so things are rapidly changing. So with rapid growth comes a lot of opportunity, right? Because no one has the answers. No one knows exactly how we're going to ultimately solve all this. And so there's a lot of opportunity to help develop this, and help shape what the future is going to look like. And so what that means is you're in the right place, right? You're in the right place in the right time. If I think about when I went to college and the different periods that I've gone back and gotten, I have several degrees. Wow, today is, talk about a great time to be. You're learning AI, security, computer science, all these different things that we're bringing together now to solve real problems at an incredible speed. So my last thought is take advantage of that, right? You're in a unique period of time in history, and everything is there for you. So take advantage of it. And with that, I thank Dr. Heaney for inviting me, and I will open up and see if there are any questions.
Any questions, guys? Any questions?
For a second there, I was afraid that I had been talking this whole time and no one could hear me and it was silent. So I'm glad you talked, Wyatt, because otherwise I was starting to worry a little bit.
Yeah, we here. We're still alive.
Okay, good.
Yeah.
All right, good.
Right.
Good.
Hey, Grant, as you know, we never know if there are agents around listening.
Yeah. The interesting thing. Yeah, go ahead.
Yeah, well, one of the good points you brought up is the boundaries around security of these agents. I wasn't really thinking in security terms, but this is a very important point and thing that needs to be worked out.
Yeah, absolutely. And I would say just from an AI, AI is, so we're in teams, right? and Teams is integrated with Copilot, right? It's Microsoft. And when you turn on the recording, you turn on transcription. Actually, the AI that's part of this whole, virtual presentation actually is recording everything, right? And it's actually putting it into an LLM and it's summarizing it. And it's, if I go back and look at what it did at the end of this, I'm actually going to be, because I always am, really impressed with what it came up with. But then there's a question of there's a lot of interesting information in here and it's being stored somewhere by an AI and processed, and where is that information going? Who is using it? Who is seeing it? Where, and these are the questions that we're really asking right now. It's really cool, like all the stuff that we can do with AI and the tools that are available to us, and we're leveraging those and using them. But thinking about the security of it is kind of lagging behind a little bit, right? Like, if you start thinking of bad actors, what could people be doing with all this stuff? And so that's, I kind of want to. Yeah.
And not just security, it is the regulations that's far behind. And that is part of the problem because, yes, you can create some guardrails around certain things, or you have to definitely run these models locally to be absolutely sure and secured and not rely on anything that's going to the web to have absolute control over it. But on a separate note, we should have some regulations around this because privacy is a big issue, and GDPR was the first really big international regulation that came around this. We need to expand on that on AI, and there's several talks I know going on, but nothing concrete, and a lot more work needs to be done.
Yeah, absolutely. I'm kind of looking through some of the questions, see if there's questions in the chat. There was one from Samuel, for interns, like, are there specific skills like natural language processing, reinforced learning, et cetera, that interns are expected? I'll tell you what we're expected internally as employees, which also is for our interns as well. We're actually in fact, mine's actually due up in a couple of weeks. We have to do internal training ourselves to really understand, and it's not specific skills, but like what does training, what are the, reinforced training or unsupervised training, right? There's different trainings of models. How do you leverage the models? What is natural language? Some of these are just, you don't have to know the specifics, but you have to understand how fundamentally does AI work? How does the NLP work? How does training work, right? Because we're actually doing that. We're going off and training stuff. We're doing things like what we say is low code or no code. In other words, you don't have to be a programmer to jump in and do stuff. You could actually be, but you have to understand the concepts, right? So for that question for interns, what do we expect beforehand? We expect you're going to have a fundamental understanding of how AI works, how training works, how you use it, what are the tools that you can use, not just from a programmatic perspective, but different things. All right, there's some questions. I know we're getting Dominique. I think you have your first hand up. I'll let you ask.
Hello, can you please hear me? All right. So my question is in agents, AI agents that have ability to make autonomous decisions. Talking about identity and access management, for these particular agents, how can the identity and access management evolve to address not just who has access, but also what an agent is allowed to autonomously decide or delegate on behalf of human identity, as we spoke about, and how can we, audit such decisions in real time?
Yeah, so this is a great question, right? And one, like I talked about, that we're still working out, right? So there's two parts to this question, right? One, how do we decide what an agent is allowed to do? And in some sense, it's like a human, right? An agent is going to, if we do high cohesion, if we look at those kinds of things, we say it's going to perform a task, and it's going to perform a task within a group. And so we can say, okay, we can get approval, that an agent is allowed to do that. But the problem with that is, the challenge with that is we may pop up 1,000 agents to perform a task. And so it overloads our governance systems. Our existing governance systems, if we have 1,000 things pop up all suddenly and want to request the ability to do something, it overwhelms us very quickly, because in today's system, there's a manual component to it, right? And a manager or somebody has to go and approve what's going to happen. So we have to change that. And so there's actually a model, ABAC, attribute-based access control, that takes a lot of different things into account. In other words, it kind of takes a person out of the loop, because the person may not fully understand what is allowed. So you look at attributes. Who is it that's asking? In this case, it's an agent. What are they trying to access? There's a whole bunch of information, and then you apply policies and rules to that to then provide the ability to what they are allowed to do. All right. And then we get into what's emerging. So we have policy-based access, we have attribute-based access. Those are kind of setting the stage for it. Now we're getting into context-based access controls, which again takes the context. Who is the agent? What is the agent trying to do? What's the actual task? Who's trying to get them to do it? And we apply that to the attributes and the policies. And so conceptually, theoretically, that's where we're heading, and we know what to do. But now we're working through that, and what does that mean from an implementation? On behalf of is actually a little bit tricky. And I know we're running out of time. And I know there's a couple of hands up. So I'll finish answering this one. I don't think I'm gonna actually. Unfortunately, I have to jump to something. So I'm sorry for the couple of people that I'm not going to be able to answer. But I ask the questions either through the chat, because I can still see the history of that, and I'll get back to people. I can get back to Fayek or Dr. Ahini. One of them, I'll get the answers back to the questions. So I apologize for not being able to answer everything, but I'll finish the other question. So when we look at between a user, we know how to do that pretty well, right? We have really good systems for users and what they're allowed to do if we understand their identity and their authorization. Now, as we build this agentic models, what does their identity look like? What does the permissions look like? Can we do the contextual based on the access for the agent? Then we have to merge. So if we're doing it on behalf of, the first set of limits that come into place is that contextual access control that we do at the time. It's a runtime decision, right? That introduces performance concerns and issues. It actually introduces a whole lot of issues, but ignore those. Those are challenges for you to help us fix. But then we look at then we fully understand about the human asking behind it, that we're doing something on behalf of, and we look at the union between those two, right? So conceptually, we understand this, but we're still working to figure out, like, in practicality, how we implement this. So, all right. I apologize again I know a couple people have their hands up. I'm looking through. I don't see any other questions, but yeah, please post the questions, and I will get back to everyone with answers. I apologize. I do have to jump to another meeting, but
Right.
I want to thank you for inviting me.
Hey, you can also send